I want you to imagine your most repetitive, energy-draining task at work.
Oh, man. We all have one of those.
Right, like you know the one. That completely mind-numbing process you have to just slog through every single day.
Yeah, the one that makes your eyes glaze over.
Exactly. Your
Yeah.
brain just completely switches to autopilot, so got it in your head.
I've got mine.
Okay, now take the stakes of that mundane task and multiply them by 1,000,000.
Wow, okay.
Because if your attention slips for even a fraction of a second, if you make one tiny mistake while your eyes are glazing over, a major artificial intelligence company gets breached.
Right, which is, I mean, that's worst case scenario.
Source code gets stolen. Proprietary model weights are just leaked to the public. Everything is ruined.
The psychological weight of that kind of environment is just crushing. I mean, you are asking human beings to perform highly repetitive, pattern-matching tasks, right?
Yeah.
But you're demanding absolute perfection because, like you said, the cost of a single false negative is literally an existential threat to the business.
It's terrifying.
It really is. And as companies grow, especially these AI companies operating at the absolute bleeding edge, their attack surfaces grow at this exponential rate.
Right. More endpoints, more cloud environment.
Exactly. More code being deployed by the minute. And you just cannot scale human analysts linearly to meet that kind of threat volume.
Okay, let's unpack this.
Yeah.
Because today, for this deep dive, we are looking at a fascinating inside breakdown from Anthropic's own engineering blog.
Yeah, specifically a post from May 2026.
Right. And our mission today is exploring how their cybersecurity team managed to solve this massive scaling problem. And spoiler alert, they didn't do it by throwing 100 new analysts into a windowless room.
No, definitely not.
They built a custom threat detection platform using their own AI, Claude Code.
Which is just a brilliant approach, but
Yeah.
to really appreciate the solution, we have to look at the foundational mechanics of the problem they were facing first.
The human misery part of it.
Yeah, exactly. The drowning analyst. We're talking about a team led by Jackie Bowe. She's the technical lead for Anthropic's detection platform engineering team.
Right, so her team is the one focusing on defensive cybersecurity.
Exactly. They monitor the network, they triage the alerts, and they investigate anomalies to stop breaches.
And it's high stakes because Anthropic has that responsible scaling policy, right?
Yes. A policy that explicitly ties their ability to release new AI models directly to their security commitments. So Jackie's team essentially holds the keys to product shipping.
No pressure or anything.
Right. But before this new platform, a typical day for an analyst on her team sounded like an absolute bureaucratic nightmare.
I was reading about this. An alert fires in the system, right?
Yep, an alert fires. The analyst opens their terminal and then begins this grueling ritual of jumping between like 5 or 6 completely different security tools. You have your endpoint detection system, your identity provider, your cloud logs.
And it's not just clicking different tabs, is it?
No. Each one of these tools has a totally different query language. Each one structures data differently. In the security industry, they actually refer to this as data archaeology.
Data archaeology. That sounds incredibly tedious.
It is. The analyst is basically forced to act as a human API layer. They are manually piecing together these microscopic fragments of data scattered across isolated silos.
So it's like, okay, think of it like trying to solve a complex murder mystery, right?
Okay, I like this.
But the fingerprints, the weapon, and the witness statements are all locked in different buildings across town.
Right.
And you have to use a completely different language to ask for the key to each one.
That is a perfect analogy.
By the time you translate the camera footage in one building, you've completely lost the nuance of what you read in the vault logs from the other building.
Exactly. You spend like 90% of your energy just translating and retrieving the data, and only 10% actually analyzing the crime.
Which just kills any kind of deep analytical thinking.
Jackie Bowe actually noted something critical about the biological limits of this process. There is a physical threshold for this kind of work.
Like your brain just gives up.
Basically, yeah. After processing a certain number of these fragmented alerts, human attention to detail just drops off.
Wow.
And she makes it clear it is not a failure of willpower or dedication. It is a fundamental limit of human working memory.
You just can't hold that much in your head.
Right. Simple investigations were burning hours, and complex, multi-stage investigations could stretch across days simply because the human brain wasn't designed to hold 6 different database schemas in mind simultaneously.
So the team looks at this reality, and they realize they're just drowning in alerts. They physically cannot work harder.
Right.
But here's the classic engineering catch-22, right?
Right.
How do you find the time to build a comprehensive automated platform when you are actively drowning in daily security alerts?
You can't.
Yeah, you can't exactly ask malicious actors to kindly pause their cyber attacks for a month while you write some code.
Which is exactly the constraint that drove the development of CLU.
CLUE, Claude Looks Up Evidence.
Right. Instead of pausing their work to build a tool, they used Claude Code to build the system while they were essentially flying the plane.
And the development timeline they published for this is absolutely staggering.
Right.
I mean, we are talking about building a custom enterprise-grade detection and response platform from scratch.
It's unbelievable.
They had a working proof of concept running in one single day.
One day.
And the design documentation, the back-end development, the full implementation, all finished in 1 week.
What's fascinating here is how they built it. Claude Code wasn't just acting as some advanced autocomplete.
Right, it wasn't just fixing typos.
Exactly. Jackie described this entirely new paradigm of software engineering where she was primarily just talking to Claude. He was acting as a real design partner.
So she focused on the big picture.
Yeah, she focused on the overarching logic, the architecture of the security checks, and the AI handled all the tedious implementation details.
The blog highlights this specific aha moment for Jackie that I just loved. She needed to add a new button to the CLUE user interface.
Oh, the UI button story.
Yeah. And normally for a back-end security engineer, tweaking the UI is a tedious slog. You're wrestling with JavaScript frameworks, you're debugging CSS grids, you're looking up all this boilerplate code.
That's the worst.
So she just asked Claude Code to do it, and it implemented the feature immediately. And then she openly admitted that the AI wrote better UI code than she would have.
Yep.
Wait, so the technical lead of an elite engineering team is admitting the AI wrote better UI code than she would have. Is it just acting as a fast typist or an actual co-founder at this point?
I mean, it's blurring the line, right? The downstream effect of that dynamic is massive. Claude Code entirely removed Jackie's technical limitations in areas outside her core domain expertise.
That makes sense.
A backend engineer doesn't need to spend 3 hours learning the nuances of a React state update anymore. The AI already have that ingested. It just collapses the time from conceptualization to execution down to nearly zero.
Okay, so they build this platform, CLUE, in a week. Let's look at the mechanics of what it actually does differently than those 6 fragmented tools it replaced.
Right, let's get into the weeds.
The system is split into 2 core functions, CLUE Triage and CLUE Investigate. Triage acts as the first line of defense.
Exactly. When an alert hits the system, CLUE performs an automated first pass before a human analyst is even notified.
And it does this through deep enrichment, right?
Yeah.
Because an isolated alert is often pretty much useless.
Yeah, like a failed login attempt. That could be a sophisticated brute force attack, or it could literally just be a developer who forgot their password after a long weekend.
Right. So CLUE takes that alert and immediately begins making direct API calls to internal systems. It checks code repositories, internal wikis, data warehouses.
And importantly, internal communication channels.
Yes. Here's where it gets really interesting.
Yeah.
The system relies heavily on internal organizational context.
Which is huge.
Think about it like a car alarm going off in a crowded city.
Yeah.
It's just noise. You ignore it because it happens every day. But if you know the car's owner is out of the country and you see a tow truck idling next to the car, that context transforms noise into a glaring signal.
That's a great way to put it.
CLUE actually checks the company's internal Slack channels. It can read the context to see if an engineer posted a message saying, hey team, I'm testing a new script that might trigger some weird database alerts.
Which is an incredible leap in utility. I mean, off-the-shelf security platforms cannot synthesize unstructured human chatter.
Right, they just look at the hard data.
Exactly. They can't cross-reference a rigid SQL database alert with a casual Slack message. But CLUE synthesizes that context, assigns a disposition, categorizing it as a false positive, malicious, or expected behavior, and then attaches a confidence score.
But just tagging an alert as malicious in Triage doesn't solve the whole problem. The analyst still needs to figure out the blast radius of that threat.
Right, you have to know how deep the breach goes.
And that's where CLUE Investigate comes in. This is the orchestration layer where analysts interact with the system using natural language. Instead of writing custom syntax for 6 different databases, the analyst just, asks a question.
Mechanically, the main Claude model acts as a sophisticated router here.
Okay, how does that work?
When an analyst asks a complex question, The model breaks that request down into discrete tasks and spins up specialized subagents.
Oh, wow.
Yeah. These subagents run parallel SQL queries across different databases, gather the raw outputs, and then synthesize them all into a cohesive summary.
Anthropic shared this brilliant example of this for data governance. Imagine you need to check if 3 specific contractors accessed any forbidden internal documents over the past 2 months.
A classic data archaeology nightmare.
Jackie noted that this specific investigation usually takes a human half a day.
At least.
Think about it. You have to pull the contractor IDs, map them to network logs, pull 2 months of access requests, filter for forbidden document tags, and cross-reference everything.
It's exhausting just hearing you list it out.
But CLUE executed the entire investigation in minutes.
And during those minutes, the system is performing an astonishing volume of actions. The internal data shows that across these investigations, CLUE averages 25 distinct tool calls and 11 complex queries per single session.
Wait, 25 tool calls?
Yeah.
Human analysts physically cannot authenticate, write, execute, and read the outputs of 25 different tool calls in a few minutes.
Impossible. But CLUE generates the verbose queries, executes them, and returns a plain language summary with recommendations.
Wait, I need to jump in here on the mechanics, though. If we have an AI autonomously generating and executing SQL queries on an enterprise backend, how are they preventing it from hallucinating a command that accidentally drops a massive production database table?
Oh, the rogue AI fear. It's a valid concern. The safety comes from strict architectural boundaries.
Okay.
CLUE is constrained by read-only, role-based access controls. It operates in an environment where it physically cannot alter or delete data. It can only retrieve it.
So it's looking, not touching.
Exactly. You are giving the AI a very sharp tool, but you are locking it inside a glass box where it can only look at the data, not touch the underlying infrastructure.
That makes sense. So this transition from manual data archaeology to this orchestrated AI investigation completely shifted the math for the team. Let's look at the actual hard metrics.
The numbers are wild.
Before CLUE, roughly 1 in 3 alerts, about 33% were false positives. Analysts were literally wasting a third of their day chasing ghosts.
Just burning time.
But with CLUE handling the enrichment and context gathering, that false positive rate plummeted to just 7%.
And the time savings compound rapidly from there. In just 30 days of deployment, CLUE autonomously executed 12,000 queries and 27,000 tool calls.
27,000.
Yeah. The engineering team calculated that this equated to roughly 1,870 hours of manual human labor.
Wow.
That is 234 person days saved in a single month.
That is a 5 to 10x multiplier on their time. But it's not just about analysts getting to go home early, right? What do they actually do with those 200 freed-up days?
It allows them to fundamentally shift their security posture. Before CLUE, low confidence alerts, the weird, weak signals that didn't look immediately critical, they were simply ignored.
Because there just wasn't enough human bandwidth to look at them.
Exactly. But now the coverage is absolute. Every single alert, no matter how low the initial confidence score, gets fully enriched and processed.
Okay, hold on. If this system is processing 27,000 tool calls autonomously, how do they actually audit it? Because in cybersecurity, trust is practically a dirty word. If an AI investigates a threat and says, hey, everything is fine, how does the team know the AI didn't just hallucinate the context or miss a deeply subtle threat vector that a paranoid human would have caught?
It is the most critical question in AI deployment right now. And Jackie's team is very transparent that measuring accuracy is inherently more difficult than measuring speed.
Right, speed is just a number.
Exactly. They solve this through rigorous auditing. The system tracks every disagreement between human analysts and the AI's dispositions.
Oh, that's smart.
But more importantly, the platform provides full transcripts of its reasoning. It is not a black box.
You can see its own work.
Exactly. It logs the exact SQL queries it generated, the exact Slack messages it parsed, and the exact step-by-step logic it used to reach its conclusion. Analysts can check the math at any time.
Okay, we have to get into the most philosophical part of this blog post. The metrics prove the system works, but the way Claude operates internally to achieve those metrics completely challenge the security industry's traditional beliefs.
Yeah, we are looking at a real-world validation of the bitter lesson.
The bitter lesson.
Right. In AI research, the bitter lesson is an essay by Rich Sutton. It observes that historically, whenever engineers try to hard-code rigid, human-specific reasoning into AI models, it almost always underperforms.
Underperforms compared to what?
Compared to just giving the model general capabilities, vast compute, and letting it figure things out for itself.
Interesting. And the blog directly referenced this, right?
Yes, because for years, the instinct in cybersecurity was to use systems called SR.
Security orchestration, automation, and response.
You got it. SO platforms rely on incredibly strict deterministic playbooks. If alert A happens, execute step 1, then step 2.
Very rigid.
But when Jackie's team stepped back and gave Claude latitude, giving it a goal and a toolbox rather than a rigid checklist, it started taking investigation paths that humans would never have prescribed. And it uncovered contexts that human workflows would have missed entirely.
Wait a minute. In cybersecurity, inconsistency is usually a massive red flag. You want a checklist. Treating non-determinism as a feature sounds terrifying. Why is this a good thing?
If we connect this to the bigger picture, you'll see why determinism is actually the vulnerability.
Okay, I'm listening.
Think about how a human adversary operates. A hacker trying to breach Anthropic is not following Anthropic's internal compliance checklist.
Right, they're trying to break the rules.
They are creative, they probe for weaknesses, and they exploit aggregated anomalies, a series of tiny, seemingly unrelated actions that only look malicious when viewed together.
It's like playing a game of chess.
Precisely. So playbooks are like a chess master memorizing an opening manual. It works perfectly until the opponent makes a move that isn't in the book and the system breaks.
Ah, I see.
CLUE operates more like AlphaZero. It evaluates the probabilities of the board state in real time. By allowing Claude to run parallel, non-deterministic investigation strategies, it actively uncovers blind spots that a rigid human-designed checklist walks right past.
So the Tuesday investigation path might connect two dots that the Monday path completely missed.
Exactly. It moves the team from a purely reactive stance, waiting for a known alert to trigger a known playbook, into a proactive threat hunting capability. The system isn't just following rules, it's dynamically probing its own environment.
Man, it is a profound shift in software design.
We are moving from teaching a machine how to investigate to giving a machine the capability to investigate, defining the boundaries, and just getting out of its way.
So let's bring this all together. We started with exhausted security analysts, essentially acting as human APIs, drowning in fragmented data, because human working memory simply cannot hold the outputs of 25 different security tools at once.
A recipe for burnout.
And then they use an AI to build an enterprise AI platform in a single week. That platform handles the grueling data archaeology, drops false positives to single digits, and saves the team over 200 days of manual labor every month.
It's incredible.
And it achieves all of this because the engineers learned to let an AI investigate like an AI, rather than forcing it to mimic the stressed-out workflows of a human.
It is the ultimate testament to what can happen when you remove the friction between a human's high-level domain expertise and the low-level execution of their ideas.
So what does this all mean for you listening right now?
That's the real question.
Whether you manage a supply chain, work in finance, or run a hospital ward, the era of human beings acting as manual data routers is ending.
Thank goodness.
The defining skill of the next decade isn't knowing the exact syntax of 6 different databases. The real skill is learning how to design the architecture. Give the AI the right read-only boundaries and context, and having the wisdom to let it find its own path to the solution.
And that reality introduces a completely new frontier of risk that we haven't even begun to grapple with.
Oh, here we go.
I mean, if an AI agent like CLUE is exponentially better at creatively hunting through an enterprise system to find aggregated vulnerabilities than any human team could ever be, well, how long until the attackers are using an adversarial version of CLUE to map the blind spots in your system before you do?
It's a terrifying thought.
Are we rapidly accelerating toward an era of purely AI on AI cyber warfare, where human defenders are just spectators watching the code battle it out in real time?
Are you prepared for an environment where the attacker has a million sub-agents probing your network at the exact same time? Something to think about. Catch you on the next deep dive.